So continuing on from the last video, we're now going to see how we can create iterations easily using Python generators. We'll also discuss how they differ from iterators and the use cases when generators are beneficial to use. Now, as you saw in the last video, there is a lot of work in building an iterator in Python. We have to implement a class using the iterator protocol. So this means we need to include the dunder iter dunder method and the dunder next dunder method in our class definition. We then have to keep track of internal states to make sure we don't run into an infinite iterator, and then we need to raise a stop iteration exception when there are no values to be returned. So there's quite a lot to remember, and it's also quite syntax heavy. Well, thankfully, we can take advantage of generators in such situations. Python generators are a simple and effective way of creating iterators. All the steps I've just mentioned are automatically handled by generators. So it takes away a lot of the thinking for us. Now, obviously, it's great to understand what's happening behind the scenes, which you now know, hence we started with the detail. So simply speaking, a generator is a function that returns an iterator object on which we can iterate over one element at a time. All we have to do is define a normal function, but rather than using the return keyword in the function, we use a keyword known as yield. Now, if a function contains at least one yield statement, it becomes a generator function. And the yield and the return statements basically just return some value from a function. The difference is that while a return statement terminates a function entirely as soon as the return statement is executed, a yield statement pauses the function and it saves all of its states and then later continues from where it left off on any successive calls of the same function. Now, when a generator function is called, it returns an iterator object, but it doesn't start the execution immediately. Seeing as methods like iter and next are implemented automatically, we can then iterate through the items using the built-in next function. Once the function runs into a yield statement, the function is paused and the control is transferred to the caller. Any local variables and their respective states are remembered between successive calls to the generator function. Now finally, when the function terminates, the stop iteration is raised automatically on any further call. So enough concept talking, let's see this in a few examples. Let's first of all create a generator function called my_generator. We can then put parentheses and a colon. We will then perform some simple logic just for illustrative purposes. So we will first of all set a variable called n to equal the number 1. This will simply act as the first number in the sequence. After we have set this, we will print to the screen, this is the first print statement in this function. Now, rather than including the return statement, which would return the object to the caller and then terminate this function, we are going to put the keyword yield instead. So we will put yield and we'll yield the variable n. This means we are now working with a generator function. I will then create two further statements by simply copy and pasting these three code lines, and rather than setting n equal to 1, I'm going to increment n by 1 each time. So we can put n plus equals 1, and we'll change the second print statement to be this is the second print statement in this function, and the third statement we will change to this is the last print statement in this function. As you can see, we're yielding n 3 times, but remembering what I said, when we run into a yield statement, the function pauses. So let's now see this generator function in action. First of all, we'll create a variable called gen1 and we'll set this equal to our my_generator function. And just to prove we're working with a generator function here, if I pass in gen1 into the built-in type function, you can see that we return generator. Now gen1 is storing a generator object, but the execution does not start immediately. We can now iterate through the elements in gen1 one by one using the next function. So if I put next and then in parentheses pass in gen1, you can see that we print to the screen, this is the first print statement in this function, and the generator function then returns 1. This is because the first statement created a variable called n and set it equal to 1. Now once the function first yields, the function is paused and the control is transferred to the caller. So gen1 is essentially paused at this point, and it remembers that the variable n contains the value 1. If I now put next and pass in gen1 again, and run this code cell, we then print to the screen, this is the second print statement in this function, and we now return 2. The function is paused at this point, it remembers that the variable n contains the value 2, and finally if I put next and pass in gen1 again, we get this is the last print statement in this function, and we return 3 accordingly. Now what do you think will happen if we run the next function again and pass in gen1? Well, when we do this, we run into that stop iteration error accordingly. And that's because this function has no further logic to execute. Now one thing to note in the example we've just run through is that the value of variable n is remembered between each call. So it went from 1 to 2 to 3 on successive calls on the generator function. Now this is because the local variables in this generator function are not destroyed when the function yields. One other thing to note is that the generator object can only be iterated once. So seeing as we run into a stop error, we'd need to create another generator object, for example gen2, in order to restart the process. Now I'm sure you've already guessed, but we can now use generators with for loops directly. And this is because a for loop takes an iterator and iterates over it using the next function. It will then automatically end when the stop iteration is raised. So if I put for I in my underscore generator with parentheses and a colon and then simply print I, you can see that we print this is the first print statement in this function, we then get 1, this is the second, we then get 2, this is the last, and we then get 3. So we're able to iterate over this iterator object, and the for loop handles the stop iteration error accordingly. Let's cover another example where a generator function reverses a string. So for example, we can create a function called reverse underscore string, and we'll pass into parentheses a parameter called my underscore string, which a user can pass an attribute into. We can then put a colon, and we'll first of all set a variable called length, which will be equal to the len of my string, so we can use the built-in len function. We can then create a for loop where we state for I in range and then parentheses. Well, we can first of all take the length and -1 from the length because we know indexing starts at 0. We can then put a comma. We can then put -1 to stipulate the stop being 0 because we go up to but not including that stop value. And we can then pass in a step size of -1, which will reverse the range. So on the first iteration, I would be 4, on the second, I would be 3, then 2, then 1, then 0. We can then put a colon and we will simply yield my underscore string, and in square brackets, we will access I. So with this generator function now created, anytime I pass in an iterable into the reverse underscore string generator function, it will reverse the string accordingly. So if I put for I in reverse underscore string and in parentheses pass in the string Python, I can then print I. When I run this code cell, we get Python reversed accordingly. Now we don't just have to pass in a string here, this function will reverse any iterable we pass in. So for example, if we pass in a list of integers 1, 2, 3, and 4, you can see that we print them in reverse on the screen. I could also pass in a tuple. Essentially, we can pass in any iterable into this function. Okay, so we've seen how to create generator functions. In the next video, we're going to take a look at how generators can be created on the fly using generator expressions. So I'll see you in the next video.